Trial version. Trial version. Trial version. Trial version. Trial version. Trial version.
And V is equal to,
Trial
what
version.
is V? And V is equal to Y minus B
version.
upon K, where B and K are constants. Then the coefficient of correlation between the new variables U and V is the
Trial
same as
version.
the coefficient of correlation between X and Y. Now we use this change of variable in class 10.
Trial version.
Try to recall, we used step deviation method. Remember that we used to subtract some assumed
Trial
mean
version.
from the values of X. That
Yes,
is
sir.
like A. And then we used to divide it by the class
size.
Trial
class size.
version.
That
Yes.
is like H.
By C.
And we learned that the mean is affected by both. That is, if you
Trial
divide by
version.
something, at the end you have to multiply by the number. If you subtract something, at the end you have to add that number. That is why we used to
Trial
add
version.
capital A.
A
to
plus
find out
N
capital
multiplied by
mean.
C.
A plus, yes. That was the formula. Here
Trial
we see
version.
that the coefficient of correlation is not affected by the change of origin or the
Trial
change
version.
of scale. Change of origin is that A or B. This is the change of origin. And change of scale is these
Trial
numbers
version.
H or K by which we are dividing. So coefficient of correlation
Trial version.
does not depend on the change of scale or change of origin. Value remains same, and that is
Trial version.
why if we introduce the new variables in order to lower the
version.
values, if the values of X and Y are very large, pretty large, in which case it will be difficult for us to calculate.
Trial version.
Though using a calculator, it is not a difficult job. But when calculator was not used,
Trial version.
then using this method was better. But nowadays, calculators are allowed, so it doesn't make
Trial
make
version.
much sense with a new variable U or V.
Trial version.
Anyway, if Rxy equal to +1, perfect positive correlation, -1, perfect negative, 0, no
version.
correlation. Number 4, when the coefficient of correlation, it lies between
Trial version.
0.7 and 0 and 1, or lies between -0.7 and -1,
Trial
then we
version.
say that there's a high degree of correlation between X and Y. If say R is equal to 0.8,
Trial version.
or say -0.85. When R is equal to 0.8, we say that the variables X and Y
Trial
have
version.
a high positive correlation, and if Rxy is equal to say minus
version.
0.85, we say that X and Y, they have a high degree of negative correlation,
Trial
high
version.
negative correlationship. So whether it is high or low or moderate,
Trial
that depends
version.
on the numerical value of R, and whether it's positive or negative, that depends on the
Trial
sign of R.
version.
So here is some notion. If the absolute value of R lies
Trial
between
version.
0.5 and 0.7, we say that the degree of correlation between X and Y is moderate.
Trial version.
And if it is between 0 and 0.5, we say that there's a low degree of correlation. Of
Trial
course, you have to
version.
mention whether it is positive or negative. High and positive, high and negative. Moderate positive,
Trial
moderate
version.
negative. Low and positive, low and negative. So whether it is high or moderate
Trial
or low,
version.
you have to mention whether it is positive or negative. That has to be mentioned.
Trial version.
Now,
Sir, what
some
is meant by
illustrations.
perfect positive and perfect negative?
Perfect positive, perfect negative.
Trial
If
version.
it is +1 or -1, that is never the case. I have never seen any sum where r is
Trial
plus
version.
1 or minus 1.
Sir, it never
it's
comes.
simple.
There
Never.
is always point answers that come
Trial
usually,
version.
Yes.
which are near one but never one.
Yes. But in case you get any sum where r is exactly equal to plus 1, of course you
Trial
will say
version.
that there's a perfect positive correlation between x and y. Simple.
Trial version.
Now, if you look at the first sum, from the given information, it is clear
Trial
that
version.
you have no choice. Covariance given, variance of x given, variance of y given. So you don't have any choice
Trial
but to
version.
use the first formula. Let me show you the first formula. This
Trial
one,
version.
covariance of xy divided by sigma x sigma y.
So
Use
we
that
should find
formula.
the square root of variance, right?
Trial
Yes,
version.
yes. Sigma x is square root of variance. Correct. So covariance
Trial
of xy
version.
divided by sigma x, you see I have written square root of variance of x, square root of variance of y.
Trial version.
Substitute to get the answer. Minus 0.97. So what would you comment?
Trial version.
There's a
Strongly negative.
high
So
and
high degree
negative
of correlation.
high and negative, yes.
Trial
In this
version.
case, these ordered pairs represent the value of x comma value of y.
Trial version.
So to find out the coefficient of correlation, make a table like this.
Trial version.
Xi and yi. Xi, look at take the first values. I mean
Trial version.
the values of x, that is 5, 7, 1, 3, and 4. Write down.
Trial
Write down the
version.
corresponding values of y, 2, 2, 4, 5, and 6. Make 3 more columns, xy,
Trial
x square,
version.
y square. Then find their sum. Okay. You don't need any help in
Trial
this. You'll
version.
do it yourself. Sigma xi, sigma yi, their sum. Sigma xy,
Trial
sigma x
version.
square, sigma y square. These are found. Here n is 5 because there are 5 ordered pairs. So n is 5.
Trial version.
And then use the last formula as I told you. Substitute the values, get the answer.
Trial
It is
version.
simple as that. Minus 0.5625. What did you call it?
Trial version.
So moderate degree of correlation.
Yes, moderate negative.
Trial version.
The other one, see, this is the example I gave you. Marks in physics,
Trial
marks in
version.
history. Any guess? Positive or negative? Correlation?
Negative.
Negative.
Trial version.
Negative. From our experience also, you may check. Take
Trial
any class
version.
9 or class 10 student, ask him, ask her. So you make the columns. Here
Trial
I
version.
illustrated this method. You see, by subtracting 7 from x
Trial
and
version.
17 from y, see the numbers are reduced. And when the numbers are reduced, it becomes easier for us
Trial
to do
version.
it mentally without the help of any calculator. That is the only advantage. It is like, you may say, this is the
Trial
shortcut
version.
method in correlation. You may say so. When you don't divide, you just subtract. That is the
Trial
shortcut
version.
method according to our class 10 mathematics. And when you subtract and divide, that is
Trial
our step
version.
division method. So here you're not dividing, you're only subtracting. The advantage
Trial
is that the
version.
numbers, the values of u and v, the new variables, they are
Trial version.
small numbers which can be easily squared or which can be easily multiplied mentally without using any
Trial
calculator.
version.
So you get the values sigma u, sigma v, sigma uv, sigma u square, sigma v square. So instead of
Trial
finding
version.
rxy, we find out ruv because we know that rxy and ruv are the same.
Trial version.
Use the same formula for ruv, just replace x with u and y with v.
Trial version.
Okay. Substitute the values. Remember n is 10 because there are 10 ordered
Trial
pairs.
version.
And look at the value. Look at the, as I told you, very
Trial
low,
version.
0.144,
Opposite.
not negative, but very low correlation.
So here we are using shortcut method.
Trial version.
So you may say a shortcut method. No, we don't call it shortcut anymore. We're in class
Trial
11.
version.
No shortcut, no step deviation. There's no name as such.
Trial version.
Is it okay? Understood?
Yes.
So simple. Now,
Trial version.
Sesha and Sumana, can you start solving from the textbook?
Trial version.
Yes, sir.
Any questions?
No, sir. No, sir.
Trial
Have you
version.
noted all the formulas?
Yes, sir.
Okay. Then I'm going to start section B with them.
Trial
They are all
version.
waiting. If you have any question, feel free to ask. I'll come back to you. Okay.
Trial version.
Ellipse.
Trial version.
So now all those who are doing section B,
Trial version.
Sir,
yes.
so in parabola, when do we use 80 square comma 280? I mean that system of
Trial
coordinates.
version.
And some places.
80 square 280, the parametric equations.
Trial version.
X equal to 80 square, y equal to 280. And there are some properties which are beyond the syllabus, ISC syllabus.
Trial version.
But there are many more properties. If you want, I can share it later. For any
Trial
focal
version.
chord pertaining to that sum which you gave me, for any focal
Trial
chord,
version.
let me show you once. Just a minute.
Trial version. Trial version. Trial version.
This is your y-axis.
Trial version.
X-axis.
Trial version. 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 Trial version.
Suppose this is the focus.
Trial version. Trial version.
Then this is a focal chord,
Trial
a
version.
chord that passes to the focus.
Trial version.
Suppose this is the point P.
Trial version.
This is the point P.
Trial
And this is Q.
version.
If the coordinates of the
Trial
point
version.
P are 8 square,
Trial version. Trial version.
280, we call this
Trial
point T.
version.
8 square 280, the point is referred to as T only, small t. Equation of the
Trial
parabola
version.
y square equal to 4ax. Y square
Trial version.
is equal to 4ax. And that is why the coordinates
Trial
are
version.
80 square 280. Then the coordinates of Q will be 1 upon t.
Trial version.
If
Y
this
square
point
equal
is
to 480.
t, if this point is referred to as t, then what will be the
Trial
point
version.
1 upon t? Can you tell me? What will be 1 upon t?
Trial version.
A upon t square?
Yes, sir.
A upon
Trial
t
version.
square?
So is it y square equal to
It is
480?
Sorry?
So is it
Trial
y
version.
square equal to 480 or 4ax?
Oh, okay. 4ax, yes. Y square equal to 4ax.
Trial version. Trial version.
4ax. For a focal chord, the condition
Trial version.
is t1 into t2.
Trial version.
t1, t2 is equal to minus 1. So if this point
Trial
is t,
version.
if this point is t, then this point q should
Trial
be
version.
minus 1 upon t. So
Trial version.
minus 1 upon t is a upon t square minus
Trial version.
2a upon t.
Trial version.
And I use this property in that sum. t1, t2 is equal to minus 1,
Trial
remember
version.
it, for a focal chord.
Trial version.
Whenever the chord passes through the focus.
Trial version.
So what is T1 and T2 here?
t1, t2 are the points on the parabola.
Trial version.
Oh, okay, sir.
See the Cartesian equation y square
Trial version.
is equal to 4ax.
Trial version.
The parametric equation, this for the same curve, the parametric equations are
Trial version.
x equal to at square,
Trial version.
y is equal to
Trial version.
2at.
Trial
What is
version.
t? T is a parameter. What is parameter? Just a variable. For different values of
Trial
t,
version.
you get different points on the curve. For any particular value of t, say t equal to 1.
Trial version.
T equal to 1 refers to the point a comma 2a on the parabola. For t is equal
Trial
to 2,
version.
t equal to 2 refers to the point 4a comma 4a
Trial version.
on the parabola. So for every single value of t, there's a point on the parabola.
Trial
So
version.
this way, if there's a point P, T1,
Trial version.
if this point is T1 and this point is T2, then if it passes through the focus, then T1, T2 equal to minus 1.
Trial version.
That is a property of focal chord. Okay now?
Trial
Yes, sir.
version.
How did we get a by T square?
Okay, if the point
Trial
is
version.
T, if T1 is T and T1, T2 equal to minus 1, what
Trial
should be
version.
T2?
Minus 1 by T1.
Minus 1 by T1, that is minus 1 by T.
Trial version.
Yes, sir.
Substitute T with, replace T with minus 1 upon T. What do you get?
Trial version.
Replace T with minus 1 upon T.
Trial version.
A by T square.
A by T square minus 2A by T.
Yes.
Trial version.
Okay, let us start ellipse now.
Trial version.
Imagine there are two fixed points F1 and F2. And
Trial version.
suppose you have placed two pins at the 2 points F1 and F2. And you have taken
Trial
a
version.
thread which is loose, whose length is more than F1, F2.
Trial
Say if
version.
F1, F2, the distance between F1, F2 is 5 centimeters, then you have taken a string whose
Trial
length is
version.
8 or 10 or 12 centimeters, certainly more than 5 centimeters. Okay. Then you're keeping the thread
version.
straight. You take a pen, okay, and put the pen here on the thread,
Trial version.
and keeping the thread tight, move the pen. The path that will be
Trial
traced
version.
out will be an ellipse. So what is an ellipse? It is the locus of a point, moving point
Trial
P,
version.
which moves on the plane in such a way that it's the sum of the
Trial
distances
version.
from the two fixed points F1 and F2 is always constant. So if I take three such points
Trial
P1,
version.
P2 and P3 on the curve, at any position, the P1, what
Trial
is
version.
the sum of the distances from the two fixed points F1 and F2? It is P1 F1 plus
Trial version.
P1 F2. This length will be the same as P2
Trial
F1
version.
plus P2 F2. When the point has moved to the point P2, then the sum of the distances from
version.
F1 and F2 is P2 F1 plus P2 F2. It is the same as P1 F1 plus P1 F2.
Trial version.
Again, suppose the point P has moved to a new position P3. Here again, the sum of the distances,
version.
that is P3 F1 plus P3 F2, will be the same as the first two, that is P1 F1
Trial version.
plus P1 F2. So you may say that P1 F1 plus P1 F2 is equal to P2 F1 plus P2 F2 is equal to
version.
P3 F1 plus P3 F2 and so on. Then the locus of the point P will be an
Trial
ellipse.
version.
So if you read this definition, that an ellipse is a set of all points in the plane, the sum of whose distances
Trial
from
version.
two fixed points in the plane is a constant. These 2 points, when the
Trial
ellipse is
version.
traced out, these 2 points will be the foci or foci
Trial version.
refer to this particular ellipse. So there are 2 foci. In case of parabola, we
Trial version.
saw that there is only one focus and one directrix. But in ellipse, there are 2 foci,
Trial version.
F1 and F2. Okay, they are fixed points. If
Trial
I
version.
join the line, if I join these 2 points F1 and F2 with a straight line and extend
Trial
it,
version.
then that line will be a line of symmetry of this ellipse.
Trial
The midpoint
version.
of F1, F2 is the center of the ellipse.
Trial
And
version.
what is a center referred to any particular closed curve? A center
Trial
is a
version.
point such that any chord that is drawn through it
Trial version.
is bisected at the point. Center is a point in a curve
Trial
such
version.
that any chord that is drawn through it is bisected at the point.
Trial version.
The midpoint of F1, F2 is one such point. If you join these 2 points and you take the midpoint,
Trial version.
you draw any chord through this midpoint, and you'll find that the chord is bisected
Trial
at that point.
version.
That is why that point is known as the center. You're only familiar with the
Trial
center of a
version.
circle. Now you see the center of ellipse. Later on, you'll find the center of hyperbola also.
Trial
So
version.
quickly, let us have a look at the properties of ellipse. So here, this is the
Trial
ellipse.
version.
There are 2 lines of symmetry. The first one joining F1 and F2 and producing them.
Trial
If they
version.
meet the ellipse at the points A and B, then the line AB, which definitely passes
Trial
through the
version.
center O, this is the largest chord through the center. The largest
Trial
chord through the center. And in fact, this is the largest chord also. And this is one of the axes.
Trial
There is
version.
one more axis which is again passing through the center and which is perpendicular to the chord AB.
Trial version.
And this chord CD is the smallest chord, smallest of all the chords. Because AB is the
Trial
largest chord and it is the axis, it is called the major axis. AB is the major axis and CD is the
Trial
minor
version.
axis. So far we have learned that this is ellipse, F1, F2 are the two foci,
Trial version.
O is the center, AB is the major axis, CD is the minor axis.
Trial version.
These 2 points A and B, where the major axis intersects the ellipse, are known as the vertices. So the ellipse has 2 vertices, vertex A and vertex B.
Trial version.
So vertex A, first focus F1, second vertex B, second focus F2,
Trial version.
major axis AB, minor axis CD. All right.
Trial version.
The length of AB, the major axis, is taken as 2A. So what is A?
Trial version.
Small a. OA or OB, this length is considered small a. And therefore the
Trial
length
version.
of AB is 2A. Similarly, OC or OD are taken as small b. Look at
Trial
this diagram.
version.
And so the length of the minor axis is 2B. So length of major axis 2A, length
Trial
of minor
version.
axis 2B. Let's move on.
Trial version.
If there's any question, ask me immediately. What is the relationship between the semi-major axis and semi-minor
version.
axis and the distance of the focus from the center? Now, what is the semi-major axis? It is half the
Trial
major
version.
axis. That is
Small a.
small a. That is OA or OB.
Trial
Let me
version.
show you the diagram again. Look at this diagram. OA is a semi-major axis. OC
Trial
is a
version.
semi-minor axis. Again, OB, semi-major axis. OD is semi-minor axis.
Trial version.
Major axis 2A, so length of semi-major axis A. Length of minor axis 2B, so length of
Trial
semi-minor
version.
axis only B. What is the relation between them?
Trial version.
See, we take 2 points. First, we take a point P at one
Trial
endpoint of the
version.
major axis. So here's the point P. You see here, the point P at the end of the major axis. Okay.
Trial version.
So by the same property, the sum of the distances of this point P from the two foci, that is
Trial
F1P plus F2P, must be constant. Suppose the length of this focus, any
Trial
focus, say
version.
F1 or F2, from the center is C. We denote this length F1O or
Trial
OF2 with C. Fine. Then
Trial
PF1
version.
plus PF2 is equal to constant. So what is the length PF1 plus PF2?
Trial version.
PF1 is, what do you see? What is PF1? PF1 is PO plus
Trial
OF1. PO is equal to A and OF1 is C. So this is C plus A. And what is
Trial version.
PF2? PF2 is PO minus OF2. That is A minus C.
A minus C.
Trial version.
So the total length is C plus A minus C, that is 2A.
2A.
So PF1 plus
Trial
PF2 is
version.
equal to 2A. Now suppose P has gone to the point Q. Then again the same property will be
Trial
satisfied.
version.
That is QF1 plus QF2 should be the same length. QF1 plus QF2
Trial
should
version.
be equal to PF1 plus PF2. We have just found that PF1 plus PF2 is 2A. And you know, this 2A
Trial
is
version.
actually the length of the major axis. That means now you have understood that wherever P goes on the
Trial
ellipse,
version.
wherever P lies on the ellipse, the sum of the distances from the two foci
Trial
is
version.
always equal to the length of the major axis. So remember this property, PF1 plus PF2 is
Trial
always
version.
2A. Now, then QF1 plus QF2 should also be 2A. Let us see what is
Trial
QF1
version.
plus QF2. QF1 plus QF2, you can see that it has formed a right angle triangle.
Trial
So
version.
QF1 is the length of the hypotenuse, which is equal to square root of B square plus C square.
Trial
QF2
version.
is the same. So you may say that QF1 plus QF2 is equal to twice root over B square plus C square.
Trial version.
Now they must be same. PF1 plus PF2 should be equal to QF1 plus QF2 because that is a property of ellipse.
Trial version.
Equate them. So now we see that
Trial version.
2 root over B square plus C squared is equal to 2A, which simplifies to
Trial
A is
version.
equal to root over B square plus C square, or C is equal to square root of A square minus B square. So now we
Trial
have
version.
got the relationship C, that is, what is C? What is C? C is the distance
Trial
between the
version.
center and any of the two foci, OF1 or OF2. So OF1 or OF2
Trial
is
version.
equal to C, which is equal to square root of A square minus B square.
Trial version.
A is the semi-major axis, B is the semi-minor axis. Clear up to this?
Trial version.
There are two special cases, two extreme cases. In one case, C
Trial
is equal to
version.
0. What happens is, if C becomes smaller and smaller,
Trial version.
if C becomes smaller, the two foci F1 and F2, they will come closer to each other. They will start coming closer to each other.
Trial version.
What happens to the ellipse then? Then the major axis becomes shorter and shorter and shorter.
Trial version.
And what will happen if C is equal to 0? What will happen if C is 0?
Trial version.
If C is equal to 0, then root over A square minus B square will be 0. So A square minus B square will be equal to
Trial
0.
version.
A will be equal to B. And if A is equal to B, look at this shape. Familiar?
Trial
This shape is
version.
familiar. What is it? It's a circle. So circle is a special case of ellipse
Trial version.
when C is equal to 0. And what happens if C is equal to A?
Trial version.
Again, look at the diagram. If C is equal to A, then what happens?
Trial version.
Then F1 and F2, they will coincide with,
Trial version.
can you tell me? If C is equal to A, then F1 and F2 will coincide with the
Trial
two
version.
vertices A and B.
Sure.
And what will happen to B? What will
Trial
happen to B
version.
then? B will become 0.
0.
And what will be the shape of the ellipse then?
Trial
B
version.
0, F1 lies on A, F2 lies on B. What is the shape?
Straight
Trial
line.
version.
Straight line. They see the ellipse has been flattened. It
Trial
has
version.
flattened like a deflated tire. Where is it? Yes. This straight
Trial
line.
version.
It's a special case. Now eccentricity E is this ratio C
Trial
to A.
version.
Again, look at the diagram. The ratio C is to A. That is OF1 is to
Trial version.
OR. Or OF2 is to OP. C is to A. This ratio is
Trial
E,
version.
eccentricity of the ellipse.
So isn't it
Trial
root over
version.
1 minus p square by s square something?
Yes,
like that?
yes, that can be, yes. When we derive this formula,
Trial version.
then you can find out. So if you, from this, now once E is defined, that E is equal to C upon A,
Trial version.
now we can substitute the value of C. What is C? What was C?
Trial version.
Root over A square minus B square?
S square minus p square.
Just put the value of C
Trial
here, you get
version.
the value of E,
Oh
the
yes.
formula for E. Okay? And here the formula is derived, so I'm not
Trial
going to the
version.
derivation. Basically, it starts from this, that QF1 plus QF2, PF1 plus
version.
PF2 is equal to 2A. If you take any point P,
Trial
then
version.
PF1 plus PF2 should also be equal to 2A. So from this is PF1,
Trial
this is
version.
PF2. PF1 plus PF2 is equal to 2A. take one root on the other side and square both sides and simplify it.
Trial version.
Remove the square root, and at the end, you'll get the equation.
Trial version.
This will take the form x square upon a square plus y square upon a square minus c square is equal to 1. Now, because
Trial
we know
version.
that a square minus c square is equal to b square, so this is the equation. X square upon a square plus y square upon b square is equal to
Trial
1.
version.
Not difficult to prove at all. The
Trial
presence
version.
of these two terms, these two variables x square and y square, x with even power 2, y with even power 2, it
Trial
shows
version.
that the curve is symmetric about the y-axis as well as
Trial
x-axis.
version.
It is symmetric about the major axis and minor axis.
Trial version.
Now, some properties of this ellipse. Yes,
So what was
Trial
x
version.
and y?
x and y, any point, the coordinates of any point P.
Trial version.
Let me show you this. Look at this diagram.
Trial
We take
version.
the x-axis along the major axis, y-axis along the minor axis, okay, and the origin coincides with the center of the
Trial
ellipse.
version.
Then we take any point P on the ellipse whose coordinates are x comma y. Then we join PF1 and PF2.
Trial version.
Okay. So PF1 plus PF2 should also be 2a. We have
Trial
seen
version.
that the sum of the two focal distances is always equal to 2a. So PF1 plus PF2 is equal to
Trial
2a.
version.
And we start with that equation. PF1 plus PF2 is equal to 2a. Then if you take
Trial
one root
version.
on the other side and square both sides, remove the radical sign, at the end you will get this equation.
Trial version.
That x square upon a square plus y square upon a square minus a square is equal to 1. And because a square minus a square is equal to
Trial
b
version.
square, that is because c square is equal to a square minus b square. So we get the equation.
Trial
Okay.
version.
Now some properties of this ellipse. Have a look. And note it down also.
Trial version.
Don't look at the second column. I'm coming to second column later. First column, x square upon a square plus
Trial
y
version.
square upon b square is equal to 1. Conventionally, a is more than b because a is a semi-major axis,
Trial
b is a
version.
semi-minor axis. Equation of the major axis is y is equal to 0. Length of the major axis is
Trial
2a.
version.
Equation of the minor axis, it is along the y-axis. So x equal to 0. Length of the minor axis 2b.
Trial version.
Directrices will be x equal to plus minus a upon e, which I haven't discussed yet. Note it down.
Trial version.
Equation of the lattice rectum, x equal to plus minus ae. Now, what is the lattice rectum? Let me
Trial
show you once
version.
again. You know what lattice rectum is?
Trial
Lattice
version.
rectum is a focal chord which is perpendicular to the major axis.
Trial version.
Yes. So you can see the
Trial
focal
version.
chords AB and CD. AB and CD, these are two focal chords which are perpendicular to the major axis.
Trial version.
So these are known as a lattice rectum. In plural, latera recta. One
Trial version.
AB is a lattice rectum. AB and CD are latera recta of the
Trial
ellipse.
version.
The lengths of these two can be easily found if we know OF2 or OF1. OF2
Trial
is
version.
the length of C. C is equal to A into E. So the coordinates of F2, AE
Trial
comma
version.
0. Coordinates of F1 minus AE comma 0. Are you getting it?
Trial
Because
version.
C upon A is equal to E, therefore C is equal to AE, therefore
Trial
OF2 is
version.
equal to AE. So the coordinates of F2 are AE comma 0. By putting
Trial
x equal
version.
to AE comma 0 in the equation x square upon a square plus y square upon b square equal to 1, by putting x equal
Trial
to
version.
AE, we will get the value of y. They are the coordinates
Trial
at
version.
A and at B. And you will find that AB is 2b square by A.
Trial version.
AF2 will be B square by A. F2B will be B square by A.
Trial
So
version.
AB is 2B square upon A. So
Trial version.
equation of lattice rectum x equal to plus minus
Trial
AE
version.
and length of lattice rectum 2B square by A.
Trial version.
Centered at 0, 0. Note it down quickly.
Trial
And
version.
the second column, this equation represents the ellipse
Trial
whose
version.
major axis is along the y-axis, vertical ellipse. That is why you see that x and y are interchanged.
Trial version.
A is greater than b, but here the greater denominator comes with y square, y
Trial
square upon a
version.
square. And so the major axis lies along the y-axis in this case.
Trial
So the
version.
first one is the horizontal ellipse, major axis along the x-axis. The second one is the vertical ellipse,
Trial
whose
version.
major axis is along the y-axis.
Trial version. 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 Trial version.
Yes, sir.
Trial
Done.
version.
Okay, now have a look at few examples.
Trial version. Trial version. Trial version.
Number 1, find the length of the lattice rectum of each of the following ellipses.
Trial version.
X square upon 16 plus y square upon 9 is equal to 1. Certainly, it is a equation of an ellipse
Trial
in the standard
version.
form, standard ellipse. Now tell me whether the major
Trial
axis
version.
lies on the x-axis, along the x-axis, or along the y-axis. How do we know?
So now x-axis A greater than B.
Trial
X-axis,
version.
because the denominator of x square is larger. X square
Trial
upon
version.
16. X square has larger number. Y square has smaller number. So 16 is more than 9.
Trial version.
That means a squared is 16 and b squared is 9. That means the major axis lies along the x-axis.
Trial version.
So comparing with x square upon a square plus y square upon b square is equal to 1.
Trial
We find
version.
that a squared is 16 and b squared is equal to 9. So a is equal to 4.
Trial version.
And the length of the lattice rectum is 2b square upon a. That is the formula.
Trial version.
Substitute. Answer is 9 by 2 units. Then can you find
Trial
out the
version.
lattice rectum of the second one? This is type 2.
So 8 by 5.
Done. What is it?
Trial version.
So 8 by 5.
Let us see. Second one
version.
is of the type x square by b square plus y square by a square is equal to 1. X and y interchanged.
Trial version.
Y square has larger number below it.
Trial
Therefore,
version.
b square is 4 and a square is 25. So a is
Trial
5.
version.
Length of Euler formula remains same, 2b square by a. So yes,
Trial
it is
version.
8 upon 5 units. Note it down. And
Trial version.
we'll move on to the next sum.
Trial version.
This type is common to parabola, ellipse, and hyperbola, all three. What is the type?
Trial version.
Focus given, directrix given, and the eccentricity given.
Trial
Focus,
version.
directrix, eccentricity. In case of parabola, E is always 1, so their focus and directrix are
Trial
enough.
version.
In case of ellipse or hyperbola, the fixed equation of the fixed line, that is the directrix,
Trial
that
version.
equation is given x minus y plus 3 equal to 0. The fixed point is the focus, whose coordinates are given
Trial
1,
version.
minus 1. E is the eccentricity, that is the ratio, PS upon PM equal to E. So E is
Trial version.
half. When these three are given, to find out the equation, we use the definition of a conic section.
Trial version.
From the
Sir,
definition of a conic
which
section,
focus is this, F1 or F2?
anyone.
Trial version.
Okay.
Trial version.
When the focus and directrix is given, see, every focus has a corresponding directrix.
Trial version.
It is understood that when the focus is given 1, minus 1, one focus given, then
Trial
that must be the
version.
corresponding directrix. So it is given also here, the corresponding directrix. It will never be given
Trial
one
version.
focus and the directrix on the other side. No, not like that. Whichever focus is given, the
Trial
corresponding directrix will be given. Okay. Nothing to worry.
Trial version.
So the focus is 1, minus 1. Corresponding directrix x minus y plus 3 equal to 0 and E is half.
Trial version.
So using the definition, let P x, y be any point on the ellipse.
Trial version.
And suppose PM is the perpendicular distance from the point P to the directrix.
Trial version.
PM. Can you visualize PM?
Trial version. 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 Trial version.
Suppose this is the y-axis.
Trial version.
Then the directrix will be somewhere here.
Trial version.
What are the
Trial
standard
version.
ellipse I'm talking about? Suppose this is the focus.
Trial version.
This is one of the foci.
Trial version.
You may call it F1. So if this is,
Trial
I name
version.
it S. Okay. Here's a
Trial
point
version.
P. Coordinates x comma y. This is a moving
Trial
point
version.
P.
Trial version.
Pxy.
Trial version.
Then I join this point P to the focus
Trial version.
and also drop on perpendicular
Trial version.
to the corresponding directrix. So I drop on perpendicular on it.
Trial version.
This foot of the perpendicular is M.
Trial
So
version.
this is M. Remember, this is
Trial
always
version.
perpendicular. And by definition,
Trial version.
PS upon PM
Trial version. Trial version.
is equal to E. Always. Is it clear now?
Trial version.
Yes, sir.
Now you may say that there is
Trial
one more
version.
focus. What about that? Fine. So there is another focus here.
Trial version.
And corresponding to this focus, there is another directrix also.
Yes.
Trial
So
version.
suppose this is the directrix. Not.
Trial version.
It should be same distance. Imagine they are the
Trial
same
version.
distance. Now why can't I
Trial
consider this focus and this directrix? Of course you can.
Trial version.
If I join from P to this point,
Trial version.
then you have to draw on perpendicular on the
Trial version.
corresponding directrix. You have to find these two.
Trial version.
You have to find the ratio of these two distances. So if I name this point, say the
Trial
second
version.
focus, suppose this is S dash. Okay.
Trial version.
And this point is suppose M dash.
Trial version.
Then I may say that P S dash
Trial version.
upon P M dash
Trial version. Trial version.
is E. Same ratio E.
Trial version.
Clear now? Any question here?
Trial version.
Have you understood?
Yes, sir.
So likewise, now it is not necessary
Trial
that the major axis will be along the x-axis. Minor axis
Trial
will always be along the y-axis. No. In general, the major axis can be anywhere,
Trial version.
and the minor axis will be perpendicular to it. So
But it's also special cases.
Trial version.
special cases. These are special cases. What we are studying now, these
Trial
are special
version.
cases. I'm
Yes.
just trying one diagram,
Trial version.
rough diagram, but you can understand. So suppose this is one ellipse.
Trial version.
Imagine this is an ellipse. Then suppose this is the major
Trial
axis.
version.
I mean, the major axis lies along this.
Trial version.
Where are the two foci? Where are the two directrices?
Trial version.
Here is one directrix, and similarly there is one more directrix.
Trial version.
Suppose this is one focus, and there's a point
Trial
P.
version.
The point P is here. So this is the point P.
Trial version.
This is the point S. Then you have to
Trial
drop the
version.
perpendicular on this line, this corresponding directrix.
Trial version.
So this is M. And PS upon PM will be
Trial version.
E. This is PS. So here PS upon PM will be
Trial
E.
version.
So no matter what the orientation is,
Trial
irrespective of the orientation of the ellipse, PS upon PM will always be E.
Trial
I hope
version.
I'm clear to you. In such case, in this case, you see that the directrix is
Trial
inclined.
version.
The directrix, this line is neither parallel to x-axis nor
Trial
parallel to
version.
y-axis. And that is the case here. Look at this diagram. Look at this sum.
Trial version.
The directrix is x minus y plus 3 equal to 0. It is neither parallel to x-axis
Trial
nor
version.
parallel to y-axis. It is inclined. Doesn't matter. PS upon PM
Trial
will be
version.
equal to E. Am I clear? No.
Trial version.
PS is equal to EPM always. Now what is PS?
Trial version.
Distance between P and S. P is xy. S is 1 comma minus
Trial
1.
version.
So this is the distance PS. Distance formula is equal to E into PM.
Trial
Now
version.
E is half. That is given. E is equal to half. What is PM? PM is the
Trial
length of
version.
the perpendicular. Length of the perpendicular drawn from the point x comma y
Trial version.
to a straight line x minus y plus 3 equal to 0. So use that perpendicular
Trial
formula.
version.
ax1 plus by1 plus c by root over a square plus b square. That formula.
Trial version.
So using that formula, the distance PM is mod of x
Trial
minus y plus 3 divided by root over a square plus b square.
Trial version.
That is root over 1 square plus minus 1 square. Equation
Trial
is
version.
complete. Now just simplify it. Remove the square root.
Trial
To
version.
remove the square root, square both sides and you get the answer. It's a very
Trial
common
version.
type. Any question here? I'll give you similar sum
Trial version.
that focus given, E given, equation of directrix given,
Trial version.
and you'll be asked to find out the equation of the ellipse. Okay?
Trial version.
Any question? Fine.
Trial
Next
version.
type. Equation given.
Trial version.
Compare the equation with a standard equation that you know. You know two standard
version.
equations. First one, when the major axis is along the x-axis,
Trial version.
center at the origin. And that is the case when the equation is x square upon a
Trial
square
version.
plus y square upon b square equal to 1. X square has larger number below it.
Trial
That is
version.
part 1. The other one is y square upon a square
Trial
plus
version.
x square upon b square equal to 1, where y square has larger number below it.
Trial
That is
version.
part 2. And there's part 3 and part 4 also.
Trial version.
In this question, you have to find out everything, like what if that is the equation,
Trial version.
find the coordinates of foci, the vertices, the lengths of the
Trial
major
version.
axis and minor axis, length of latus rectum, and the eccentricity.
Trial version.
All, everything. How do you do it?
Trial version.
Take the equation. Identify the type, whether the
version.
major axis along the x-axis or y-axis, whether the equation is comparable with
Trial
x
version.
square upon a square plus y square upon b square equal to 1, or the other one, that is
Trial
y
version.
square upon a square plus x square upon b square equal to 1. If I call
Trial
them
version.
type 1 and type 2, type 1 where the major axis along the x-axis, type 2
Trial version.
major axis along the y-axis. For my quick reference, I'll say type 1, type 2. So is it
Trial
type 1 or
version.
type 2?
Type 1.
Type 1. So we compare
Trial
it with
version.
x square upon a square plus y square upon b square is equal to 1.
Trial
And
version.
by comparing, we get the value of a square and b square. A square is 25, b square is 9.
Trial version.
From these two, we get the values of a and b. A is 5, b is 3. That is
Trial
enough.
version.
With these values, we can find out everything. Everything.
Trial version.
First, we need to know what is the eccentricity E.
Trial version.
The formula for E, and note it down, for an ellipse. E is
Trial
equal to
version.
square root of 1 minus b square upon a square. Actually, E is equal to
Trial
C by A, which I showed earlier. E is equal to C upon A. But C is equal to root over a square
Trial
minus b
version.
square. So it actually comes from root over a square minus b square, whole divided by a.
Trial version.
Same formula. Root over 1 minus b square upon a square.
Trial version.
And this gives the value 4 upon 5.
Trial
Any
version.
doubt up to e? Have you understood?
Trial version.
Yes, sir.
Okay. If you have any question, feel free to ask.
Trial
Don't hesitate.
version.
Don't keep your doubts to yourself. Always discuss.
Trial version.
Cosine. The coordinates are plus minus ae comma 0.
Trial version.
Substitute the values. We know a. Just now we have found e.
Trial version.
Just substitute them. Get the coordinates plus minus 4 comma 0.
Trial version.
Note this down. I'll ask you to solve other questions.
Trial version.
When I'm solving part 1, I may ask you to solve part 3. Okay.
Trial version.
Look at the steps. How do you do it?
Trial
Vertices.
version.
Vertices are always at plus minus a0. So plus
Trial
minus 5,
version.
0. Length of the major axis, which is 2a. We
Trial
have found a
version.
equal to 5. So 2a is equal to 2 into 5, that is 10 units.
Trial version.
Length of the minor axis, 2b. We have found b 3 units.
Trial
So
version.
2b is equal to 6 units. Major axis 10 units. Minor axis
Trial version.
6 units. Length of latus rectum,
Trial
2b
version.
square by a. That is 2 into b square is 3 square. 2 into
Trial
3 square by
version.
a, that is 5. 18 upon 5
Trial
units.
version.
And e we have already found at the beginning. Eccentricity
Trial
e is
version.
4 upon 5. Any questions?
Trial version.
Sir, what are the foci
Trial
for
version.
x square by b square plus y square by a square?
You tell me. Tell me what is the
Trial version.
distance between the center and focus? Which is C,
Trial version.
isn't it?
Yes, yes,
I'll
sir.
show you the diagram.
Yes, sir.
Trial version.
It will help you. Look, OF2 or
Trial
OF1
version.
is actually C.
Yes, sir.
Now we know that C
Trial
upon
version.
A is equal to E, isn't it? C
Yes.
upon A is equal to E. So what is the value of C?
Trial version.
AE.
A.
If C is equal to AE, what are the coordinates
Trial
of F2
A comma 0
and F1?
minus a
version.
comma 0.
So combined, you can we say plus minus A comma 0?
Yes, sir.
Trial version.
Now give this ellipse a rotation through 90 degrees.
Trial
So this
version.
will be of type 2. But the
Then
distance
it will
between
become
Trial version.
0 minus a.
yes, correct.
Trial version.
Irrespective of the orientation, the distance between the focus from the center will always remain
Trial
C,
version.
that is AE. Always. Center to focus
Trial
AE.
version.
Remember. Center to focus AE, center to vertex
Trial
A,
version.
and center to directrix. Directrix is not drawn, but if I draw the
Trial
directrix,
version.
center to directrix will be A by E. I'm showing it here.
Trial version.
Imagine the directrix is here. Suppose this is the directrix.
Trial version.
Then distance from center to directrix will be A by E.
Trial
A
version.
upon E. A
Trial version.
upon E. This is the distance from center to the
Trial version.
directrix. So remember these three.
Trial version.
Center to focus
Trial version.
AE.
Trial version.
Center to vertex A.
Trial version.
Center to vertex A.
Trial version. Trial version.
Sir, why is it A by E?
Trial version.
Why is it?
How did we get A by E?
You can derive it.
Trial version.
I'm not going to the derivation now. You can derive it easily using definition of ellipse.
Trial version.
If I get time, I'll come back to it.
Trial version.
I'm in a hurry to solve few problems so that you
That
can
is
solve.
from PS by PM equal to E.
Trial
From there
version.
we
Yes,
can get.
yes.
Trial version.
So this is fine. Now
Trial version.
this one, x square upon 4 plus y square upon 25 equal to 1. Type 1 or
Trial
type
version.
2?
It's type 2.
Type 2. So what is
Trial
a square? What is b square? Clearly a square is 25, b square is 4.
Trial
Larger one is always a square. So a square 25, b square 4. A
Trial
is 5, b is 2. Yes, understanding?
Trial version. 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 Trial version.
First determine
Trial version.
whether it is type 1 or type 2. Can you tell me? Look at the
Trial
vertices.
Type 1.
Type 1. Who said Ashram?
Trial version.
Boydurju.
Boydurju. How could you say type 1?
Trial version.
One vertex at 0, the other vertex at 0, minus
Trial
10.
version.
It's not type 1.
Yes.
Vertical, isn't it?
Trial version.
Type 2.
Type 2. Yes.
Trial
And
version.
the midpoint of the two vertices is the center. So which is the midpoint of
Trial version.
0, 10 and 0, minus 10? It is 0, 0.
0, 0.
So
Trial
it is
version.
clear that the ellipse has its major axis along the y-axis.
Trial version.
It has its center at the origin. So we can
Trial
consider
version.
the equation y square upon a square plus x square upon b square is equal to 1.
Trial version.
But you have to find out a and b. How do you find a and b?
Trial version.
Looking at the equation, looking at the information given,
Trial version.
vertices at 0, plus minus 10. What can we find out?
Trial version.
From the
B is
coordinates,
Trial
see,
version.
every vertex is at a distance of a units. Every vertex is at a distance of
version.
a units from the center.
A equal to 10.
Trial
So a
version.
is equal to 10. And if we know E also,
Trial version.
there is a relation between A, B, and E. What is the relation?
1 minus B square by A square equal to A.
Trial version.
Correct. So, first, vertices at 0 plus minus 10.
Trial version.
Therefore, center at 0, 0. The major axis is along the
Trial
y-axis. A is equal to 10. We get all these informations.
Trial
E is
version.
4/5. And we know that there's a relation. See, note it down. Note down this
Trial
relation.
version.
B square is equal to A square bracket 1 minus E square. Basically, it is the same relation.
Trial version.
That E is equal to C upon A, or E is equal to square root
version.
of A square minus B square upon A, or E is equal to root over 1 minus B square upon A
Trial
square.
version.
Same formula. If you square both sides,
Trial
you will get this
version.
relation. But it helps. B square equal to A square bracket 1 minus E square.
Trial version.
Using this relation, A square, that is 10 square, bracket 1
version.
minus E square, E is 4 upon 5, substitute, we get B square equal to
Trial
36.
version.
So we know A 10, the value of A is 10. We know the
Trial
value
version.
of B square is 36. What else do we need? What is the
Trial
equation?
version.
The equation is therefore y square
Trial version.
plus x square upon b square is equal to 1. That is,
Trial version.
X square by 100 plus Y square by 36 equal to 1.
so this is the equation.
Trial version.
So now you have got some idea. Hope you can solve part 2.
Trial version.
Yes, sir.
Can you tell me? Foci at 0, comma plus minus 4.
Trial
What information
version.
do we get from this? E is 4/5.
Type 2.
Type 2.
Trial version.
Very good. Type 2. Center at the origin.
Yes.
Trial
Major
version.
axis along the y-axis. What is the distance between the center
Trial
and the
version.
focus? Again, the same question.
Trial version.
Once again,
AE.
AE, correct.
Trial version.
So can you say AE is equal to 4?
Yes, sir.
Trial
Yes.
version.
So we get center 0, 0, major axis along the y-axis.
Trial
AE is
version.
equal to 4. AE is equal to 4 and also E equal to 4 upon 5.
Trial version. Trial version.
A
Again, use the same relation. That is, B square equal to A square
Trial
bracket 1
version.
minus A square. Remember it. Just few formulas.
Trial version.
Very few formulas. So you get B square equal to
Trial version.
9. Now we know A, we know B square. What is the equation?
Trial version.
Y square upon A square plus X square upon B square is equal to 1.
Trial version.
So the equation Y square upon 25 plus X square upon 9 is equal to 1.
Trial
Yes.
version.
Understood?
Yes, sir.
Trial version.
Now think about part 3. How do you proceed?
Trial version.
Foci given, and it is given that it is passing through the
Trial
point
version.
4, 1. That's all. From the foci, it's plus minus 3, 0.
Trial version.
What do you get? It is type 1 or type 2?
Type 1
Trial version.
and AE.
Type 1, correct. And also AE is equal to 3,
Trial
Yes, sir.
version.
isn't it? AE is 3. Type 1 ellipse, AE is equal to 3.
Trial version.
It passes through 4, 1. Now what do we do?
Trial version. Trial version.
We did the equation. X square upon A square plus Y square upon B square equal to
Trial
1.
version.
That is the equation. Type 1. X square upon A square
Trial version.
plus Y square upon B square is equal to 1. This ellipse passes through the point.
Trial version.
Which point?
Trial version.
4, 1. So put x equal to 4, y equal to 1.
Trial version.
And you get the equation 4 square upon a square plus 1 square
Trial
upon b
version.
square is equal to 1. That is
Trial version.
16 upon a square. Now,
Trial version.
we use the relation b square
Trial
equal to
version.
a square bracket 1 minus e square.
Trial version.
Can you find a now? Do we know e? Is it given?
Trial version.
So a equal to 3. From there we can find value of a.
Yes.
Trial version.
So it is actually a square minus a square is square. That is 16 upon
Trial
a square
version.
plus 1 upon a square minus 3 square.
Trial version.
Can you see that? 16 upon a square plus 1 upon a square
Trial
minus
version.
3 square is equal to 1. Can you find a square from this?
Trial version.
Yes, sir.
Find a square.
Trial version. 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 Trial version.
If you have difficulty in handling with a to the power 4, because in the equation
Trial version.
you'll get a to the power 4 then a square, I would suggest you may substitute a square
Trial
with
version.
something like
Yes, I did that.
m e and then
Trial
solve.
version.
So has anybody got the value? A square.
Trial version.
Sir, is it 12?
Trial
Not 12.
version.
A square is not 12. It is
Trial
not 12.
version.
So 64 and 324, something like that.
Trial
Don't say
version.
something like that. Give me the answer, solution. It's not that difficult to.
Trial version.
If I take a square equal to p
Trial version.
or m, suppose a square equal to m. So the 16 upon
Trial
m
version.
plus 1 upon m minus 9 is equal to 1. Find m. Just like this.
Trial version.
Yes, sir. 64 and 324.
Trial version.
64 and 3.
324.
Trial version.
64 and 324. Are these the values of a square and b square?
Trial version.
No, what are you talking about? I want the
Trial
value of a
version.
square.
Trial version.
What is the value of a square?
Trial version. Trial version. Trial version. Trial version. Trial version.
So 2 root 2 and 3 root 2.
Why two
Trial
values?
version.
Are you getting two values of a square?
No, sir.
Trial
Value of
version.
A. What value of A?
Value of a will be only
Trial
one value of a. Are you getting two positive values of a square?
Yes, sir.
Trial version.
So which value should you choose?
Trial version.
Say for each value of a, you have to find the corresponding value of b, and remember a is greater than
Trial
b.
version.
Now give me the value of a or a square. We actually need a square, not
Trial
a,
version.
but fine.
Trial version. Trial version.
For each value of a, you have to find the corresponding value of b,
Sir,
Trial
keeping in
version.
mind that a is greater than b.
So A square equal to 18 and B square equal
Trial
to 9.
version.
Now you got the value. Yes, a square is 18. A square is 18 and b
Trial
square is
9.
correct.
Trial version.
A square 18, b square 9, and therefore the equation of the ellipse is
Trial version.
x square upon a square plus y square upon b square equal to
Trial
1.
version.
That is x square upon 18 plus y square upon 9 is equal to 1.
Trial version.
Is there any question?
Trial version.
No, sir.
Okay, good.
Trial
Last
version.
one on ellipse. Find the equation of the ellipse with center at the
Trial
origin,
version.
major axis on the x-axis, and satisfying the following conditions.
Trial version.
Number 1, length of major axis 8, e is equal to
Trial
half.
version.
One question. Second question, length of minor axis is
Trial
equal to the
version.
distance between the foci, and length of LR. Yes, I'll call that, let us
Trial
term
version.
LR. Length of LR 10. Number 3,
Trial version.
it passes through the points 4, 3 and minus 1, 4.
Trial version.
Okay. So let's begin with number 1. How do you find the
Trial
equation?
version.
What do you get from this information? That length of major axis 8. That
Trial
means
version.
A is 4.
A is 4. Very good.
And B square equal to A square minus
Trial
A square
version.
into 1 minus A square. So we can get
Correct.
value of B square. Then
Yes.
we'll substitute in the
Trial
equation.
Correct.
version.
Good. That's easy. So find out A square, find out B square, and find the equation. Tell me.
Trial version.
All of you, please try. And while solving, if you face
Trial
any
version.
difficulty, you can clear your doubt.
So X square by 16 plus B square
Trial
by 12
version.
equal to 1.
Let's see now.
Trial version.
So A is 4. And because E is equal to half, so B
Trial
square is
version.
equal to A square bracket 1 minus A square. Using the same formula, we get B square
Trial
equal to
version.
12. And therefore the equation, it is given that the
Trial version.
ellipse with center at the origin, major axis on the
Trial
x-axis.
version.
That means type 1 ellipse. And therefore the equation x square upon a square
Trial version.
plus y square upon b square is equal to 1. So the equation x square
Trial
upon
version.
16 plus y square upon 12 is equal to 1. Part 2.
Trial
Now
version.
what do you do? Read the given information.
Trial version.
Length of minor axis, that is 2b. Length of minor axis is
Trial
equal to
version.
the distance between the foci. Now what is the distance between the two foci?
Trial version.
Let's have a look at the
Trial version.
Yes,
2C.
2c. And what is c?
Trial version.
In terms of a, b, e, what is c?
Trial version.
Oh, C is
Trial version.
root over A square minus
C is simply
Trial
ae. ae.
I.
C by a is equal to e, so c is
Trial
equal to
version.
ae. Remember, note it.
Trial
C is
version.
equal to ae. So what is the distance between the two foci?
Trial version. 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 Trial version.
Has anyone got the answer? A or B?
Trial
Sir,
version.
x square by 100 plus y square by 50 equal to 1.
I think you're right.
Trial version.
Now look,
Trial version.
we know that b square equal to a square into 1 minus e square. That is b square equal to a square minus ae whole square. But because a is equal to b,
Trial version.
so b square equal to a square minus b square. You may have a different approach, but
Trial version.
I did this way, which implies 2b square is equal to a square.
Trial version.
But because b square equal to 5a, so 2b
Trial
square is
version.
equal to 10a from part 2. 2b square, that is 2
Trial
into
version.
5a, 10a. So 10a is equal to a square. Obviously, a is more than
Trial
0.
version.
We will consider a greater than 0. So the value of a is 10.
Trial version.
Now because a is 10, therefore b
Trial
square
version.
is equal to 5 into a, that is 5 into 10. So b squared is 50.
Trial version.
A is 10, so a square is 100. And therefore the
Trial
equation is
version.
x square upon a square plus y square upon b square equal to 1. That is
Trial
x square upon
version.
100 plus y square upon 50 is equal to 1. Good.
Trial version.
Now the third one. Only 2
Trial
points
version.
given. The ellipse passes through the points 4, 3 and minus 1,
Trial
4.
version.
Only 2 points given. What do? We know that the
Trial
equation, we know that the ellipse is of type 1 ellipse,
Trial
whose
version.
equation is of the type x square upon a square plus y square upon b square is equal to 1.
Trial version.
All you have to do is to find the values of a and b. Now this curve, this
Trial version.
equation, this ellipse passes through 4, 3. So put x equal to 4, y equal to 3.
Trial version.
Where? In the standard equation, x square upon a square, that is
Trial
16
version.
upon a square, plus y square upon b square, that is 9 upon b square.
Trial version.
16 upon a square plus 9 upon b square is equal to 1. Equation number 1.
Trial version.
Similarly, substitute x equal to minus 1 and y
Trial
equal to
version.
4. We get 1 upon a square plus 16 upon b square is equal to 1.
Trial version.
Equation number 2. From these two equations, find out a square and b square.
Trial version.
And tell me.
Trial version. Trial version.
These are the
Trial
equations.
version.
After solving, you get a square equal to
Trial
247 upon 7, b square equal to 247 upon 15.
Trial
Let's not
version.
waste time. Take it down. And after finding a square and b square,
Trial version.
simply substitute in the equation. X square upon a square plus y square upon b square equal to
Trial
1.
version.
So, equation
Trial version.
7x square plus 15y square is equal to 247.
Trial version. Trial version. Trial version.
You'll find basically two types of questions.
Trial
In
version.
one, equations given, and you have to find out the details, the other properties
Trial
of the
version.
ellipse, like center, focus, vertex, equation of
Trial
directrix,
version.
length of Euler, and so on. And the other type is some conditions given,
Trial version.
and you have to find out the equation of the ellipse, like this. These are the types.
Trial version. Trial version.
So if you don't have any questions, any other question on this ellipse,
Trial version.
then I would like to discuss a the fundamentals of
version.
hyperbola. Is it fine with you?
Trial version.
Yes, sir.
Because
version.
hyperbola is very, very similar to ellipse. That is the reason.
Trial version.
So that you can start solving.
Trial version. 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 Trial version.
In case of hyperbola, the property is a
Trial
little
version.
different. How we define ellipse? The locus of the point P
Trial version.
such that the sum of the distances from the two fixed points F1 and F2, that is
Trial
PF1 plus PF2 is equal to constant. In case of hyperbola, the locus
Trial version.
is that PF1 minus PF2. The absolute value
Trial
of
version.
PF1 minus PF2 is always constant. That is the difference of the two
Trial
distances is constant. Wherever P lies, the
Trial
difference
version.
in the distances from the two fixed points F1 and F2, that is absolute value of
Trial
PF1
version.
minus PF2 is constant. That is how hyperbola is defined.
Trial version.
So in the diagram, P1 F2 minus P1 F1, difference between the
Trial
two
version.
distances. Look where P1 is. Find the distance
Trial
of
version.
P1 from the two fixed points F1 and F2. P1 F1 and P1 F2.
Trial version.
Because here P1 F2 is larger, so P1 F2 minus P1 F1. Or suppose
Trial
when the
version.
point lies on P2, P2 F2 minus P2 F1. Or when the
Trial
point
version.
P lies here at P3, then P3 F1 minus P3
Trial
F2.
version.
Larger distance minus smaller distance. Always constant.
Trial version.
This ellipse, this hyperbola has two branches. These two branches.
Trial version.
They may look like parabolas. So it may look like a pair
Trial
of
version.
parabolas, but it is actually not. They are not parabolas.
Trial
So you can
version.
see there are two lines of symmetry. One, obviously, the line joining the two foci, F1 and F2 are the foci. So this is one axis. And the
Trial
other one
version.
is perpendicular to F1, F2, passing through the midpoint, passing through the center.
Trial version.
The points where the line F1, F2 cuts the
Trial
hyperbola,
version.
look at they are called vertex. So there are two vertices. Look at this vertex. The point
Trial
of
version.
intersection of the line F1, F2 with the hyperbola. So first vertex, second
Trial
vertex.
version.
First focus, second focus.
Trial version. Trial version.
Okay.
Trial version.
So in this diagram, the vertices are at A and B.
Trial version.
I'll just show you the formulas,
Trial
equations,
version.
so that you can start solving in the next class.
Trial version.
Everything is similar to ellipse. Like eccentricity,
Trial version.
again E is equal to C upon A.
Trial
Very
version.
similar. I'll take you straight to the equations.
Trial version.
The line joining
Trial
the
version.
two vertices A and B is called the transverse axis.
Trial
The line
version.
AB is called the transverse axis, and there are 2 points on
Trial
this
version.
line, y-axis, which is perpendicular to the line joining
Trial
AB,
version.
passing through the center. There are 2 points which are. I'll show you the diagram.
Trial version. Trial version.
Not here. Yes.
Trial version. Trial version.
So, what is the equation?
Let me show
Trial
the
version.
conjugate axis. There's no diagram.
Trial
If there's
version.
a complete diagram, I can explain everything from that. I'm just looking for it.
Trial version.
Anyway. Then I have to refer to
Trial
this diagram
version.
only. This one
Trial
only.
version.
Then the vertice is not
Trial
marked.
version.
Anyway, the distance between the two vertices is
Trial
2a.
version.
And there are 2 points on the y-axis
Trial
which
version.
are at a distance of b, small b. So a point on the
Trial version.
y-axis, b units above the origin and b units below the origin. That is
Trial
0
version.
comma b and 0 comma minus b. That is the conjugate axis. Transverse
Trial
axis
version.
2a, conjugate axis 2b. Then the equation of this hyperbola,
Trial
there are
version.
2 standard hyperbolas. This is type 1 hyperbola, whose
Trial
equations
version.
So,
Trial
which is the
version.
transverse axis and the
transverse axis is the line joining A
Trial
and
version.
B. There's no complete diagram here, so
Trial version.
I'm looking for one
Trial
diagram in which
version.
everything is given. Otherwise, don't worry, I'll discuss in the next class.
Trial version.
Not labeled properly.
Trial version. Trial version.
This AB, the line AB, do you see? A
Trial
and B are the
version.
2 vertices. So this line segment AB is the transverse axis.
Trial version.
And there are 2 points on the y-axis.
Trial version.
Not actually y-axis. In this case, it lies on the y-axis. It is the line
Trial
which is
version.
perpendicular to AB and passing through the midpoint of AB. That is passing through the
Trial
center.
version.
On that line, there are 2 points. One is B units above it and the other one is B units below
Trial
it.
version.
That is 0B and 0 minus B. The line joining 0B and 0 minus B, that is the conjugate axis.
Trial version.
which one is the vertex?
Vertex A and B.
Trial version.
Oh,
Let me see if I find a better
Trial
diagram here.
version. Trial version. Trial version. Trial version. Trial version.
No, okay.
Trial
Okay, so let
version.
me explain from here only.
Trial version.
Look, this is the transverse axis.
Trial version.
This is the transverse axis. There's a
Trial
point
version.
here, 0B, this point, 0B, and 0 minus B.
Trial version.
This is the conjugate axis, 2B.
Trial version.
Then the equation is x square upon a square minus y square upon
Trial
b square is
version.
equal to 1. Like ellipse, the sign in between is
Trial
minus.
version. Trial version.
Equation of the transverse axis. That is the x-axis
Trial
itself.
version.
Y is equal to 0. Equation of the conjugate axis. It's on the y-axis
version.
here. So x equal to 0. Length of transverse axis. You see,
Trial
this is
version.
A. This is A. And
Trial
this
version.
line segment also A. So length of transverse axis 2A. And
Trial
this
version.
is B. B here
Trial version.
and B here. So length of conjugate axis 2B.
Trial version. Trial version.
So the vertices are plus minus a comma 0,
Trial version.
Plus minus A comma 0.
and the
Very
foci are
simple.
plus minus a comma 0.
Foci A comma 0, plus
Trial
minus A comma
version.
0. Everything is here. Look. Very similar. Length of transverse axis 2A.
Trial version.
Foci plus minus A comma 0. Equation of lateral septum
Trial version.
x equal to plus minus A. Just like ellipse.
Trial
Length of
version.
lateral septum 2b square by A. Same. Center at 0, 0. This is for type 1
Trial
hyperbola,
version.
where the transverse axis is along the x-axis. And if
Trial
we
version.
interchange x and y, that is y square upon a square minus x square upon b square equal to 1,
Trial version.
then the transverse axis lies along the y-axis, center at the origin. Then this is the
Trial
equation.
version.
You see, x and y are interchanged. Now it is y square upon a square minus x square upon b square equal to 1.
Trial version.
So there will be change everywhere. Now the equation of transverse axis will be x equal to 0,
Trial
and
version.
equation of conjugate axis will be y equal to 0. But the length of transverse axis remains same, 2a.
Trial version.
And length of conjugate axis also remains same, 2b. Though it is not mentioned here. Length of conjugate
Trial
axis,
version.
2b. Foci plus 0 comma plus minus a, because now in this case the
Trial
two
version.
foci lie along the y-axis, on the y-axis. So 0 plus minus a.
Trial version.
Again, the distance between the center and focus, it remains
Trial
AE.
version.
Equation of Euler, in this case y equal to plus minus AE.
Trial version.
Length of Euler, 2b square by A, and center
Trial
0, 0.
version. Trial version.
The two directrices will be somewhere here.
Trial version.
One directrix here, someone like this, and the
Trial
other
version.
directrix at the same distance on the other side. Maybe somewhere here.
Trial version.
These are the two directrices. The equation of this directrix will be
Trial
x equal to what? Tell me. X equal to
Trial version.
A by E. And the equation of the other directrix,
Trial version.
x is equal to
minus a by e.
minus A by E. Correct.
Trial version.
Difficult to write.
Just
equal to minus A by E.
Trial version.
Minus A by E. So combine the equation x equal to plus minus A by E.
Trial version.
Okay, you can see plus minus A comma 0. And the later
Trial
septum will be
version.
like this. This is 1. And
Trial
this is the other
version.
one.
Trial version.
Okay. Same for here. Type 2.
Trial version.
Clear? So we'll solve problems on this hyperbola next class. But you
Trial
may start
version.
solving. Sums are similar. Concept similar. So you may try few sums on
Trial
this.
version.
Next class we'll complete conic sections, all the
Trial
types.
version.
And if you have any difficulty, write down all the difficulties or send it to me in the
Trial
group.
version.
We'll discuss there.
So what is left in conic sections?
Trial version.
Left in where?
So conic sections.
Conic sections, okay. Identification of the conic. That is general equation of second degree.
Okay, sir.
Trial version.
So the equation is given. So like ax square plus 2hxy plus
Trial
by
version.
square. See, if the equation is like this, some equation is given. Ax square
Trial version.
plus 2hxy
Trial version.
plus by square.
Trial version.
So it has all the terms. By square
Trial version.
plus 2gx is plus
Trial version.
plus 2gx
Trial version.
plus 2fy
Trial version.
plus c. C is a
Trial
constant.
version.
Is equal to 0.
Trial
Which
version.
curve will it represent? That is the question. You are given an equation like this,
Trial version.
which has x square, xy, y square, x, y, and constant, everything.
Trial version.
It can be a circle, a pair of straight
version.
lines, a parabola, an ellipse, a hyperbola, anything.
Trial version.
So how do you determine what is the type? That is identification of conic
Trial version.
under general equation of second degree. This equation is known as the general equation of second degree.
Trial version.
So that is left. A little
Okay.
bit. Just few formulas.
Trial
That's all.
version.
Okay. So if you don't have any other questions, any other
Trial
questions,
version.
any other doubt, then we'll meet next
Trial
week.
version.
Good night, everybody.
Good night, sir.
Trial version.
Happy New Year, sir.
Happy New Year.
Trial version.
Thank you, sir.
Trial version.